Now let us take examples on vector products. We recall that vector products, if we have two vectors A, which is a1i plus a2j plus b3k, or a3k rather, and similarly if we have B to be b1i plus b2j plus b3k, then we can evaluate the cross products. That will be A cross B, and it will result into simplifying, okay, just A cross B. As A cross B, it will result into simplifying into in the form of a 3 by 3 matrix, determinant of a 3 by 3 matrix. So this will be components of A, A1, A2, and A3, and this will be component of B, B1, B2, and B3. So for more understanding on this, please refer to the lesson video on matrices, where we talked about the determinants of 3 by 3 matrix. Okay, now let's take an example. Furthermore, when we want to evaluate the magnitude with the angle between the two vectors, so it will be modulus of A, modulus of B, sine theta. Let's take an example now. We're given that A is equals to 4i minus 3j plus 2k. Likewise, B is equals to I plus 2j minus 5k. So from here, we can see that this is A1, this is A2, and this is A3. Likewise, B1, which is 1, B2, which is 2, B3, which is minus 5. So we can easily evaluate A cross B. So A cross B, we have the unit vectors ijk. So we'll write the components of A1, A2, and A3. So A1, A2, and A3, A1 is 4, A2 is minus 3, and A3 is 2. Similarly, B2, B1, B2, and B3, B1 is 1, B2 is 2, and B3 is negative 5. So the next thing on the line is to simplify this using the determinants process of a 3 by 3 matrix. So that means we are using the place signs of positive, negative, and positive. So we'll begin with positive I. In positive I, numerator, the column and the row being crossed, so we are left with minus 3, 2, 2, minus 5. Minus 3, 2, 2, minus 5. Similarly, we move on to minus j, which is this. So we eliminate the row and the column, and we are left with 4, 2, 1, minus 5. So this will result into 4, 2, 1, minus 5. In the same vein, we move on to positive k. Positive k. And in positive k, the row and the column, and we are left with 4 minus 3, 1, 2. 4 minus 3, 1, 2. And then we apply the principle of a 2 by 2 matrix, the determinant of a 2 by 2 matrix, where we have A, B, C, D, where we have to evaluate the determinant, the leading diagonal AD minus the following diagonal CB. So with that, we can move on and apply this principle to this line. So applying the principle to that line, we will have that this will become positive I. The leading diagonal, that's minus 3 multiplied by minus 5. And the following diagonal, that's 2 multiplied by 2. Okay, negative. 2 multiplied by 2. Minus 3 multiplied by minus 5. And we move on to minus j. So we take the leading diagonal first, that's 4 minus 5. 4 multiplied by minus 5 minus the following diagonal, that is 1 multiplied by 2. And finally, plus k. We take the leading diagonal, 4 multiplied by 2 and the following diagonal, 1 multiplied by minus 3. Okay, so please, for more understanding, refer to the lesson video in matrices. And let's proceed on. So this will result into positive I into 15 minus 4 minus j, and this will be minus 20 minus 2 plus k. We will have 8 minus 3. So if we simplify this all together, this will result into 11i plus 20j. Okay, before we proceed, that's plus positive I into 11 minus j into minus 22 and plus k into 11, and if we resolve this all together, we will have 11i plus 22j plus 11k. So this is A cross B. So we can evaluate A, the modulus of A cross B. Now we notice that A cross B here is a vector quantity. So we can evaluate the modulus, and this will be the square root of 11 squared plus 22 squared plus 11 squared. And if we resolve this, that's the square root of 11 squared plus 22 squared plus 11 squared. It will give us an estimation of 26.944. And we'll be applying this. I know you have been saying this formula: A equals B modulus of A modulus of B sine theta. We'll learn about what this system means and how to evaluate it when we are dealing with the angle between two vectors. Now let's take another example. That's question 2. We're given that P is equals to 2i minus 3j plus 4k. Likewise, Q is equals to 5i plus 4j minus 3k. And we are asked to evaluate P cross Q. Okay, now we know that P cross Q will be I, J, and K in a 3x3 matrix format, and this will be P1, Q1, P1, P2, and P3, and this will be Q1, Q2, and Q3. So what is P1? P1 is 2, P2 rather is minus 3, P3 is 4, 5 is Q1, 4 represents Q2, and minus 3 represents Q3. So if we make this substitution, you will have that this will be IJK, and P1 2, P2 minus 3, P4 is 6, is 4, P3 is 4, Q1 we have 5, Q2 we have 4, Q3 we have minus 3. So let's rewrite that. P cross Q is equals to 3x3 determinant format, 2 minus 3, 4, 5, 4 minus 3. So now what we just have to do now is to reduce this 3x3 into a 2x2 determinant format, just like we did in the last example. So let's apply it. We begin with the place sign: positive, negative, positive. And when we are starting with positive I, go column, we are left with minus 3, 4, 4, minus 3. So we have minus 3, 4, 4, minus 3. Similarly, we move on to the next, that's minus j. and we have row and column and minus j. We are left with 2, 4, 5 minus 3. That's 2, 4, 5 minus 3. And then we move to positive k. Positive k. So we take the row on this, the column on this. So we are left with 2 minus 3, 5, 4. So that's 2 minus 3, 5, and 4. So applying the principle of 2 by 2 matrix determinant, that's A, B, C, D, which will be equals to AD minus BC. So with that done now, we apply it to this place, and we say from here, positive I, so this will be minus 3 multiplied by minus 3, minus 4 multiplied by 4, minus j, we begin with the leading diagonal, that's 2 multiplied by minus 3, and 5 minus 5 multiplied by 4, plus k, 2 multiplied by 4, minus the following diagonal, that is 5 multiplied by minus 3. Watch more videos or lesson videos on determinants of a 3 by 3 matrix in the playlist of matrix. So let's move on. That's positive I, and this will result into 9 minus 8 minus j, and this will result into a minus 6 minus 20, and plus k, this will result into 8 minus 15. So let's solve this together. We have positive I into 1 minus j into 26 plus k into 23. So this will give us I, okay, 1i I minus, this is minus 26, so this will be positive 26j plus 23k. So we have seen how to evaluate the cross product of P and Q. We have also seen how to evaluate the cross product of A and B. And all we just did is just to apply the principle that A plus B is solving like in a determinant of a 3 by 3 matrix. And then we have this. Now let's take an exercise on vector product.